So we are in the middle of 3-4. Let's see a few things here. I did send you guys a study guide. Let's see how today goes. But I'm thinking most likely test next week-ish. We're good. Go from there. But let's go with it. Any homework questions from 3.3? That's what we're finishing up here. Give me the numbers. 59. 19, 21. You got it, guys. Go for it.
How I got 19, but I did. I looked at the answer and I was like, that's correct.
Okay, let's see what Isabel magically did. So 17 to 19, let's go. Let's see, use the properties of logarithms to rewrite to simplify the log expression here. So log base 4 of 8. This guy for 17. Anybody? Any takers on this one here?
What's the base?
Base is 4. Then you have to tell me what Bob says about it as well. Bob, he's a cool guy.
I didn't write down the correct one. Oh, no, I sure did.
Sure, yeah, absolutely. Let's go with it here. So the product property would split this guy up, especially if you want to get the same base, right? Something at 8 is 4 times 2. So if that's the case, then log base 4 of 4 times 2 is there. Split them off. Let's see, if things are being multiplied, we think we add them together, right? So plus. And then it'll be log base 4 of 2. Voila. Anybody with this guy here? Log base 4 of 4? 1. And then the question is, what is the back of the book? Is that what it says, or has it went on beyond that? 2/3, okay. So now let's keep on going. How do you get to 2/3? That's eventually what I want right there. 2/3 or 3/2? I think it's 3/2. 3/2, okay. So the answer back of the book, Bob says it is 3/2. So the question is, how do we get to 3/2 here?
Because if you do the other one, base 4 is 2, or whatever. You're adding 2 totals together.
How do you get, what do we need here? It's 1, right? So how do you get a 1/2 out of it? That's the question.
1/2 is the same thing as the exponent of 1/2 is the square root. The square root is 2.
Oh yes, look at this, guys. Check this out. Let's see if this makes sense here. Isn't 2 really just the square root of 4? There it is. That makes sense. It's the square root of 4. Let's keep on going now. 1 plus. Now log base 4 of square root of 4 makes 4 to the 1/2. Is that true? Square root of 4 is 4 to the 1/2. I think we're going somewhere. Now I'm going to do is I'm going to use the product property. No, the power property. There you go. The power property to put this little 1/2 in front. And now the question is, what's log base 4 of 4 again? Da, da, da. And then 1 plus 1/2 eventually gets us what we need. You guys comfortable going 1 and 1/2 is 3/2? You guys are Algebra 2 students. We know how to do that. It's the Algebra 1 folks. Boom. Are we good? Sweet. Okay, so this is what I was talking about the other day. There's the fact that you kind of look at the back of the book to see if you match, and then how do you sort of get to that answer? Because we technically could have stopped here. 1 plus log base 4 of 2, right? And you're like, okay, I'm done here. That's about as simple as I can get. And then there's like, why is it only at 3/2? Why is it all gone? Why are the logs all gone? Okay, 17 good now? And Isabel, now do you know why you miraculously got that answer? Okay, that was 17. Moving on to 19. 19 is log base 5 of 1/250. Whoa, okay. Anybody talk to me? How do we get this here? Quotient property. Okay, let's do that here. I've got 2 things that are being divided. Therefore, we are going to subtract. And now the 250 gets to go up on top for us. Okay. Anybody just going with whatever people say here?
Also, I didn't do this correctly, but is this log value 1 0?
Any log to the base of a base to the 1 power will be 0. So that goes away.
And you get negative 1 times 2.
Okay, now the question is back of the book. Bob says, what's the answer to this guy?
Negative 3 minus log 5 2.
Say again, -3?
Minus log base 5 2.
-3 minus log base 5, 2? Huh.
I got there. But
Okay. Only thing I'm thinking here would be that would work. In fact, maybe for some of the homework assignments, especially when you look at a base right here, we're thinking about exponents, right? So maybe 5 to the 1 or 5 to the 0 is 1. That's easy. That's 5. 5 squared, at least have that in your mind, is 25. 5 cubed is 125. Oh, yes. That's why I want to split this off. Because 125 times 2 is going to be 250. So log base 5 of 125 times 2. Now, when I split this up, the only thing you got to be very, very careful for is this little negative here. Now, I got to put a parenthesis here now. Good there. I got to put that little parenthesis there because the negative has to go to the first term, also to the second term. So whenever one term becomes 2 or more terms, you have to put a parenthesis in there. Okay, I think I got this now. So negative log base 5. 125 is really just 5 to the 3rd power. And log base 5 of 2, there's nothing I can do to reduce that. Okay, anybody? Log base 5 of 5 cubed.
Move the 3 to the front, and then log base 5 of 5 is just 1.
Cool. Or like this, Landon. Instead of doing two steps, right? We could just say, what exponent do you put on 5 to give you 5 cubed? It could just go straight to 3, and that's just a little bit faster as opposed to 2 steps. So 3. So whenever you see this here, let's kind of write this in. So I think this is one of our properties, isn't it? Log base b to the x is just x. So 3 plus log base 5 of 2, and now we put in the negative here. So -3 minus log base 5 of 2. Voila, love it. So now the other. Oh, yes. Okay, so real quick here, as long as you're right with the correct answer correctly, you're fine. There's about 10 different ways to do this problem based upon which property you use at what time. So good there. So let's jam to 21. 21. Now we have ln on our hands, so we've got to just kind of be mindful of that. Ln and e will undo each other's work as long as we can put them together. So I got two things that are multiplying each other. That's cool. So ln of 5 plus ln of e to the 6th. So again, one of two ways that we're talking about here, ln of e to the 6th, what you can do is you can just cancel those out. It becomes a 6. Or you can do it as a 2-step. You bring the 6 out in front, ln of e, those get crossed out, and then you get the 6. Any which way is going to work. So real quickly here, I'm going to go like this and ask you, what does Bob say again for this one? Six plus ln of 5, ln of 5 plus 6, that means the same. We're good to go on that one. Okay, 21 good. Okay, and 59. 59. All right, this is the 4th root of all of this right here. Whoa, this is crazy. Okay, let's unpack this. It says what? Use the properties to expand this equation. So first things first, I am going to you can put brackets if you like. Oh, I'm missing a parenthesis here. Sorry. Let's use a small parenthesis and a bigger parenthesis. Okay, that little 1/4 is a little problem here. Let's bring it out in front. 1/4 ln of all this good stuff here. All right, so here's a little issue. We're going to break up one thing into two things. And if that's the case, we're going to have to put a parenthesis with brackets here. So it's going to be 1/4 of ln of x cubed plus ln of, and this guy it needs its own parenthesis because it has stuff inside the ln. All right, talk to me. Is there any other way I can simplify this or expand this out? Absolute power. Let's see, the 1/4 goes in, but this guy can also go out. I think some of them, it says make the expression inside the log as simple as you can. And so x cubed can still be simplified by taking that 3 out in front. Now that's about as simple as I can get. I can't get any more. This one, even though it's x squared plus 3, that's as simple as I can get. I can't get any more simple than that. Now we multiply the 1/4 times here gets us what, 3/4 on x? Got a 1/4 ln of x squared plus 3 done. Okay, is that what Bob says? Hey, but you're just saying just to say it, or you?
No,
Okay. Dylan.
We also go over 73 or 77.
377. So this is now going the other way. So 59 is expanding things out. And 61 and on with the homework is condensing it as one big giant log function here. So let's go 73. So we got ln of x minus, we got a 4 on the outside. And so notice we're just doing everything in reverse. Okay, let's handle that big old bracket first. Let's see. So let's leave this on the outside for now. So that little, so let's put this together. So there's a multiplication between the two. Therefore, it's going to be x plus 2, x minus 2. Anybody? Can you tell me what that's going to be right there? X plus 2, x minus 2. If you multiply. I go with that. So it would be x minus 4. All right, all right. I'm thinking this little 4 on the outside becomes the exponent on the inside. So how about 4th, x squared minus 4 to the 4th? Good there? You guys talk to me. That's good. Yes? Yes. And then we have ourselves ln of x over. Let me write the ln a little larger here. So we've got a minus sign here. That means divide between the two. The one in front of the minus sign goes on top. The stuff in back of the minus sign goes in the bottom. And boom, are we good? Cool. Okay. What time are we out of here? 35. Okay. Let's see if we have enough time to finish up. So that was 3.3 homework. Are we good? Let's keep on going. We are in 3.4. And how is 3.4 so far? Good, bad, or really bad? Last time we looked at exponential functions, right? So notice in all the times that we've solved equations, we had something and the exponent was, the x was in the exponent. Notice it was, let me just bring in an example here. Let's say it's something like this right here, right? And in fact, this is your homework question, I believe. That's an exponential equation, right? And that was what we did on Wednesday. We move on and we're gonna do log equations. Hey, that's pretty cool. I'm so glad we did the properties of logs, because now we're gonna try to solve something that looks like this. So ln of x is equal to, or plus, we could say plus. Okay, so gear up, there's a few nuances here that we've got to think about here. So now this is called a logarithmic equation. Logarithmic. Okay, are we good? They kind of, I think in students' minds, they kind of get mixed up between the two, but you got to think about, okay, what am I doing? Where am I at? Oh, I'm doing this equation. Okay, this is those steps for that. So I like the fact we separated it out into two different days. We did these here. So let's start off pretty easy and work our way to more complicated ones here. Before we get started here, on each of these, you are going to round to 3 decimal places. So raise your hand if you need a calculator. The one that sits closest to me, they get a choice. I'll take it down. You doing okay? I think we should, yeah, let's go. I think we should be able to finish up here with this. So what example problem are we on? First of all, that'll help out. Or which,
Should be
what,
example 8,
this should be example 8?
or no, example 9, sorry.
This should be example 9, no problem. Let's go with the easy stuff first, and we'll work our way to more complicated stuff. So ln is equal to 2. I'm going to solve this to 3 decimal places. I want to know what x is, so solve for x. That's my question. Now we're stuck, right? Because we're stuck inside an ln function. So let's go with it here. So first things first, we kind of have two different log functions here. For the most part, allow you 2 different choices to do this. You could put in a base. You can always put in a base if you like. Or you could always change forms. And they look the same. So put in a base, we're going to stick in the base, we're going to stick all this inside the exponent. We're going to do the reverse of taking out a base earlier. Okay, so what base should we put in to get rid of ln's? E, of course. So here's what I'm going to do. I'm going to put E here. This stuff's going to go in the exponent. E goes here, and that stuff goes in the exponent. What's so special? Do we have any properties that says something about e to the ln of x? Let me see if I can thumb back through our notes here real quick. Dun, dun, dun. I have this funny looking property in 3.2. That said this right here. It said e to the ln of x is equal to x. It's on page 234. It's property number 3. Absolutely, because the e and the ln function, they undo each other's work all the time. I think if you go back in our minds, remember how we did this right here? If it's 5 log base 5 of, let's say, 125, right? I think that's the problem we used. What exponent do you put on 5 to give you 125?
3.
3. And then what is 5 to the third?
Oh, yeah.
Yeah, we start off with this one and we finally finish up with that one because you're undoing the work of the others. You can't really show it with E and ln, but the property is still the same. So instead of doing that right here, what we do is we just chop it. We good? Okay, that's one way. So let's chop E and ln, and voila, I got an answer. That's the exact answer. Can you give it to me in 3 decimal places? Accuracy. Can you punch in 2 to the E to the 2? 9. Perfecto. Okay. The other way to do these, and this is the better, I mean, this is the more common way of doing it. You could also change forms. Logarithmic form changes it to exponential form. What's my base? To this log function. E. What's my exponent? 2. What was the term inside the log? Oh yeah, I like that. Is that a little faster? Yeah, so if you change forms, it's faster, but in most math textbooks, you do the base all the time because it works all the time. Okay, are we good there? So change a base or put in a base. Change forms or put in a base. Okay, let me just throw some more complicated ones at you, but I think we'll be okay. And we're going to go just a little bit faster as well. Just we got. So let's go with ln. Let's do a little simpler still here. Let's stick with ln just for a little bit here. Can you guys finish off this one? I'm going to go with the one that works all the time. I'm going to go put in a base. So notice the ln is all by itself on one side. That's cool. I'm going to put in a base of e on here. That takes everything into exponent, everything here. So put in a base. Cancel off these guys. Okay, and then we usually don't write exponents of 1. We'll leave it there. What should we do to solve for x? By 4, I would go with that. So on your calculator, here's the exact answer. Can you give it to me in terms of 3 decimal places? Gotcha. Yeah. Actually, Abe, can you show that to me here? Points. What's the? Give me like
7, 9.
Perfect. That's what I want to show you guys. So we want to go round off to 3 decimal places, and sometimes students get mixed up on this one here. So if I'm rounding this off, if there's a 9, I look back, I do need to round up. So at this point, since this still has to be 3 decimal places, it's going to be 0.680. You got to put in the 0 there because it's the next. We still consider an units digit. Okay, 0.680, we good. More complicated, let's go. Okay, tell me to slow down if I'm going a little too fast. We good? Example 11. 2 minus 6 ln x is equal to 10, all yours. All right, anybody with clues how to do? Trying to get x by itself? Can't do it yet because I don't have the ln by itself. I only do that if I have ln on one side and nothing else there. So let's get rid of everything that's not ln of x on the left. Can we subtract 2 from both sides? 6 ln of x is equal to, what is that, 8, is that right? We'll divide through by -6 on both sides. ln of x is equal to, oh, -1.33. So that means it's negative, let's see, 4 over 3. That's probably what it is. That's cool. Okay. You guys say put in a base, is that right? Now we've got ln all by itself. Are we good there? That cancels, and I'll go up with x is equal to e to the -4/3. Are we good? Give me approximate answer. Okay. 0.264. Perfect. All right, you guys ready for your thinking caps? So let me do one more other thing here. Think about the graph for ln and the log functions here. Can you guys describe the graph for me? Does it have a vertical asymptote? It's at 0. Remember the vertical asymptote at 0? Okay. And I think it goes like this. Is that right? It goes like this and then turns, correct? Okay, here's my little issue. The domain. Are all the numbers allowed to be used? No, only numbers that are higher than 0, correct? Oh, we got ourselves a little problem. Hold on. So we've got to do this here. On log functions, whenever you get your final answer, you have to think about, does it fit into this domain? You got to do it all the time. With exponents, we didn't care, because exponents, you can handle any x you like. But ln functions here, log functions here, they have that domain restriction on their hands. All right, so real quick here, if we're to plug in 2.264, we just make sure that when we're going to be taking the log of something or ln of something, we're taking it of a positive number. Okay, so punch in 0.264 to there. Are we taking log of a positive number? Yeah, we're good. Let's go back to example number 10. If I were to punch in 0.68 and I multiply it times 4, now notice there's a multiplier now. Am I taking log of a positive number? Yeah, then we're good. We can accept that answer. So over here, ln of 2, which is 7.389. If I punch it in, am I taking log of a positive number? Yeah, that's easy enough. Okay, let's go to example number 12 then. ln of x plus ln of x minus 2 is equal to 1. Da, da, da. Ten more minutes. I think we can finish up here. Okay, so let's go with it. If you want to go ahead of me, go for it. Otherwise, what I don't like, I don't like to see two ln functions. Can I combine these guys together as a single function? I see addition on my hand, so how about ln of x times x minus 2? Oh, that's cool. At least I have the ln by itself. I'm going to multiply this out. So how about ln of x squared minus 2x? What do we do now? put in a base. Put it into the exponent. Ln's cancel, and I'm left with this right here. Oh man, that does not look good. I'm trying to solve for x. Is that right? So how about this? How about I move the e over? And do you guys see something called a trinomial in your hands? I see x squared, I see an x, and then I see a loner number. Say again? That does not look good. Factoring, maybe? What do you guys say? I don't think so. Not with e. So quadratic formula it is. Oh boy, boy, boy. Okay. Let's think about this here. X is equal to, let's see, opposite of 2 or negative b plus or minus b squared minus 4 times a times c all over 2 times a. Are we good there? Wow, this is going to be interesting. So let's see, multiply that times that. That makes, tell me if I'm right. You guys, am I right there?
Yes.
Okay.
Please cancel out the negative plus and minus here with both for you.
Yeah, we can actually even take out, can we take out, because these are both 4s, we can take that out. Everybody good there? And then we can cancel these guys by 2. Okay, yeah, that's about as simple as we get. On your calculator, just real quick here, what is 1 plus the square root of e? $2.64. Okay, keep that up. And then what is, this is 1 plus root e, 1 minus root e. Negative 0.649, okay. All right, so let's talk about this here. Can't use the second one because of, it's a negative, right? If I were to plug in a negative 0.649 into here, so we reject it. Does the 2.649 work? And real quick here, it doesn't work because it's a positive 0.62.69. It works because when you plug it back in, into here, and also into here, when you take the log function, you'll take a log of a positive number. We're good? It's not so much as the answer is positive. Once it's re-plugged in, you're taking the log of a function. So it actually was okay, barely, right? Because notice over here, it's going to be 2.649 minus 2. So the time, yeah, so ln of 0.649 is still positive, so we're good there. Done. Okay. So x, finally, I get an answer of 649. Are we good with that? Anything last one here? Last one. Let's jump to, I know I've been dealing with ln's here. Let's jump to like a regular log function. You guys will see those on the homework as well. So how about log base 3 of x minus log base 3 of x minus 8 is equal to 2. Sorry guys, hold on one second here. Oh, that's gonna be class, sorry, did I mess up? Yeah, I messed up. This should be a plus sign. Boom, boom, boom. All right, we've got 4 minutes left, all yours. Can you guys do it yourself from beginning to end? The only thing I changed is I got a log base 3 now on my hands instead of E. So give you guys about a 30-second head start. Let's jam here. So I got a plus sign here. I got to put logs together. So how about x times x minus 8 equals to 2? Then I can multiply that out as well. So how about x squared minus 8x? Notice it's the same exact process, right? Each time you put the logs together, you put in a base. Now this one, base e or base 3? Give me the base 3 this time. We have been using e just because it was ln. So notice in this one, it actually works out nice this time. It's just 3 squared. These guys are gone. This becomes x squared minus 8x, and this guy becomes a 9. Love it. Scoot it over, set equal to 0. And I need two numbers, multiply negative 9, add to negative 8. That should be pretty easy. Negative 9, positive 1. Set equal to 0 and solve. I got a positive 9 on my hands, and I got a negative 1 on my hands. Negative 1 cannot work. Once I plug it in, it gives me negative 1 here. It actually gives me negative 9 here. That's gone. The 9, let's see, plugged into this one. That works over here. Over here, ooh, barely works. It barely scraped by because I still had to subtract 8. Real quick here, if these numbers were 7 and negative 1, I would reject both of them. We're good? Because it would, 7 works here, but it would not work here. In this case, it's 9. Done. Okay. Real quick here with the minute left here, I just want to show you how to punch these guys into your calculator and sort of see things here for the 101, the application problem here. Pause here. I think I still have, no, I don't have the calculator out yet. As you guys will be doing these problems here on the homework, we got 30 more seconds, 45 more seconds left here. Can you guys punch this into your calculator and graph it? So V, this is millions of cubic feet of acreage of a forest.
That's 6.7.
Say again?
That's 6.7 or
6.7. This is, notice what I said about the E function, the ln function is called the natural log, right? The natural function. So we're modeling the growth of a forest based upon age. As the trees grow, and it's growing in terms of cubic feet.
So we're just graphing that equation right there.
Yep, can you graph that equation for me? Get a good window for it as well. So y equals, let's see, 6.7. Where is the E function? The E function is right over here by ln.
What is the decimal?
Negative 48.1.
Is it
Divided by, being divided by, in this case, you're going to press X because that's your variable there. Click enter. And let's see the graph of this guy.
Yeah. It's like right next to the y-axis.
Next to the y-axis, Okay, and we got to finish up here already here. So zoom, maybe zoom in, right? You may have to find it. It's right here. Notice it's like so
Like really
small.
small.
So just real quick, I know past time here. If I extend the x-axis to 60, let's say, I wonder if we get something here. Oh, look at that. There it is. I extended the x-axis way out to 60. Finally get my graph because it took all this time. Remember how the E function, they start off small for a while and then eventually starts growing? That's that little aspect, so you got to get that. So that's to start on your homework for 111. Anyway, with that, we're done. Enjoy the weekend here. I'll see you guys on Monday. You too, thanks.
Thank you, Mr. Collins.